Okay, welcome back. What I want to look at is statistical diagrams, okay? And we looked at that previously in another video before this, okay? But there's that much information to be presented that it has to be done in its own right. Okay, right. Let's move on. That's your contents, okay? That's what we're going to be looking at: frequency, polygons, questions, keywords, cumulative frequency, and questions, okay? Now, a frequency polygon is formed by joining the midpoints of the tops of the bars in a bar chart by straight lines, okay? So what you're looking at here is you're taking a line from 0 to the midpoint of your bar. Now, the bar could be any width, variously, depending upon what your diagram has been designed to do, okay? Then from here, you'll draw another line to the center point of this, then to the center point of here, then to the center point of here, okay? And so forth. Okay? Now, to make sure we get that's a frequency polygon, okay? Let's just make sure we get that into frame for you in full, okay? Okay, good. Example of frequency polygon. So let's look at a process. The number of passengers on the 0656 train from Brighton to London was recorded for 36 days. Now, how many days was it recorded for? It was recorded for 36 days. Okay? And here are your data, etc., etc. This lists your data. Now we need to put our data in a sequence that we can manage and we can follow sequentially and easily. So this data can be put into a grouped frequency table. Now we have a group frequency table. So here we have number of passengers, now our 51 comes from the data we have collected. So we can see that here in our data collection there is nothing below 52. So on sequence of number of passengers is 51 to 60, and the tally is 5. Now if you count how many passengers we got, 52, '53, 2, 55, that makes 3, 59, that makes 4, now it's possible I missed something out here, so let me just check. Okay, 52 once, 59, yes, 2, 53, I give this 3, I give this 4, and that gives us 5. So we can see that our tally is 5. Number passengers between 51 and 60 is 5. Frequency occurs as 5. And then we go on to 61 to 70, etc. 5, 6, etc. 12, 10, 3. Okay. Now make sure that you can see the data for itself, because the data is what you will actually need to carry out your calculations and draw your relevant graphs too. Okay. So here we have now, we've plotted our graph, example frequency polygon, number of passengers on the 0656 Brighton to London. Now number of passengers, 51 to 60. For me, I would have just classed it as 50 to 60 and 60 to 70, etc. 70 to 80. That's the way I would have gone with this myself. It's a lot, make it a lot easier and more equal, but that's only my opinion. Okay, and the cumulative frequency we got, as we said, here's 5, etc. We got 6 here, okay, and here we got 12 between 71 and 80, okay, and then we have only 3 at between 91 and 100, okay. And that's where you plot your now your decision how you make these squares is up to you, but often you'll find that it gives you a good idea to have these, to use 2 squares rather than just the one, to get an even or a spacious graph. Okay. Michelle did a survey of the cars passing her house. She recorded the results of 100 cars. Okay, and there's your results. Number of people, okay, frequency 10, 35, etc., etc. Now draw a bar chart to show this data. On the same graph, draw a frequency polygon. Okay, let's have a look. Frequency, traffic survey, number of people in cars, okay? So you can see that 10 times occurrence at 10, we only had 1 passenger in a car. Then number of people in a car, then we had a frequency where we then have 35 people. Now this is quite, I would say, an exaggerated frequency, so forth. So keep that in mind, but make sure that you look at information for yourselves, okay? And that the information that you're looking up is quite appropriate. Now also, do some self-research as well, just to make sure that you understand the criteria in regards to frequency and your X and Y axis, okay? Now words, keywords, interquartile, let me just get this, make sure we get this up for you. Interquartile range, cumulative frequency, median, upper quartile, low quartile, frequency, okay? Let me just pan out so we can get this in, okay, fully. Now upper quartile, low quartile, the distance on the horizontal scale between the lower and upper quartiles, the frequency is added up as you go along. Exactly 1/2 way up the cumulative frequency axis, and then of course then down and read off the other axis. Now exactly 3/4 up the cumulative frequency axis, and then across, then down and read off the other axis. exactly a quarter up the cumulative frequency axis, and then across, then down and read off the other axis, and that's in reference to your lower quartile. Now the frequency tells you how often a particular result was obtained. Okay, so let me just pan back, make sure we get this in fully. Okay. Okay. Now cumulative frequency. Cumulative frequency means adding up the frequency as you go along. When plotting a graph, plot the point using the highest value in each class. Cumulative frequency is always plotted up the vertical axis. All values and ranges are read off the horizontal axis. Okay, so let's have a look at that. Now again here, this is just reference to quartiles and interquartile range. Now you need to do a little bit of research for yourself on this as well, okay? And make sure that you understand the concept behind each section. I'm not going to try and do it here in this video because it can be quite cumbersome, especially when you have to put in data or write it up. But it's important that you write out some of the information for yourselves and make it your own. Okay? Okay, and this is for you to be able to read now. All being well, you should be able to read this yourselves. You pan back, make sure we get it all in. Okay, good. We have. Now an example. In a survey, 200 teenagers were asked to state their weekly pocket money. The results were plotted as a cumulative frequency curve. Cumulative frequency, weekly spending money, okay, was £1 to £6. So you can see here that 20 people had a weekly spending money of £1. You can see here that 100 people had spending pocket money of £100. Yeah. Okay. Now again, recheck your information, look up and confer in regards to other maths books. The stacks here, you cannot go wrong. Do some research on the internet if you prefer. If you are looking at cumulative graph to show spending as such, or just for information on cumulative graphs. Okay. And here we have the median. Okay. Upper quartile. Okay. And your lower quartile. Okay. And you look back at what we were talking about quartiles. Let me just go back one. Okay, a second. To go back one. Okay, and this is the information you need first to remember that how to read off the information in regards of that. Okay, so let's go back forward. Okay. Okay. Example: upper quartile, 75% of 200 equals 150. Using the graph reading across from cumulative frequency of 150, the spending money at that point is £3.60. Okay. Lower quartile, 25% of 200 equals 50. Using the graph reading across from cumulative frequency of 50, the spending money at that point is £2.20. Let's just have a look and see if we can come back on that. Okay. Yes, smack on exactly. Okay, here's your £2.20. Weekly spending money would be worth approximately £2.20, and it would follow on. Okay, 50. Good. Okay, now read this. Keep the information in mind. Okay. Right. Example: upper quartile 75%, lower quartile, etc. etc. Yes, you know already. Let's go with that. And here we're simply saying that, in other words, 25% of students spend £2.20 or less each week. And that is correct according to our graph. Okay, make sure we pan out. Okay. And here it's just telling you now what's happening in respect of the graph, so you can read that for yourself. In other words, 50% of students spend £3 or less each week, and 50% of students also spend more than £3 each week. How many students spend exactly £3? Let's go back a bit, okay? And how many students spent exactly £3? Let's go back and just have a look and see how many students spent exactly £3. And I'm going to look at the graph, okay? 100, okay? Okay, 100, that would be, okay? Look back at the graph, it gives you the information that you need. Okay. Shape of the cumulative frequency curve. The shape of the curve is like an S shape. The shape of the S indicates how spread out the data values are. Now, a tight S curve close to the median indicates a tight distribution and a small interquartile range. A tight distribution represents very consistent results. Example: lifetimes of batteries or light bulbs, all very close to the median, represent a more reliable product compared to another product where the lifetimes show a wide variation. Okay. Okay. Now, shape of the cumulative frequency. Okay, let me just make sure we get that in. Okay. A longer, more flowing S curve further away from the median indicates a widely spread set of data and a larger interquartile range. Cumulative frequency against marks out of 10. So purely as an example, okay. Okay, questions. The length of gills here is measured in centimeters. Okay. Now again, this is for you to follow and do. Okay. I don't need to do anything further on this. Okay. Find the interquartile range. Okay. Find the median range. Oh, okay. That's okay. I was just checking something for myself. Okay. 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 And here's our answers, okay? Okay. Length of girls here in centimeters. So you can see that you can see here that approximately we could say about 7 girls may have had their hair at 30 centimeters. You can see here that about 15, 18 girls might have had their hair at 40 centimeters. Okay, so that's what we're looking at. Let's see what else we can tell you. Now remember, make this your own. You can plot the graphs using the information for yourself, but use graph paper to plot your graphs. Okay, it gives a more accurate reading. It practices you for when you're in school and you're doing the work. It gives you and it prepares you to sit for your exams as well. Get the work done. Do the practice for yourselves. And just to show you what they're talking about here, okay, this information here comes from here, okay, comes from here, this table here, okay, this graph. So make sure you use it, okay. And if you look back further, you'll see the name of each section of these are given a name, okay. Length of snakes in centimeters. What have I missed? Hang on a second. Okay. Length of gills here. Yes, okay, I got that. Answers, yeah, that's my answers. Okay, let's go. Answers. Length of snakes in centimeters. That must have been from the previous section, which I probably haven't even seen or may have missed, but interesting. But anyway, you get the gist, okay? Don't hang on long on any errors. We will always make errors. That's a natural part of living. Okay. Okay, answers. And again, this is just giving you for example, a working example, okay, again, okay. Okay. Okay, here I don't need to say anything much because you would have done this similarly already. It's just showing you a different graph using a different data. Okay, that's all. Okay, thank you. That's good. I hope you will find this useful. Have a good day. Bye bye for now.